Okay, you guys, so this is the beginning of Chapter 3, Lesson 2. We're going to estimate products. Now, I know you guys don't like estimating, but I'm going to make this as easy as possible. So just follow along and do the best you can. Okay? Now, the question for this lesson, actually for this whole chapter, will be, how can estimating be useful? There is a point to estimating. There's a goal here. Now, for this particular lesson, the goal is basically to estimate products using rounding. Okay, there are rules to follow if you want to estimate the product of decimals. You have to round them. Why? Well, the whole goal is to make the math easier to do in your head. Okay, mental math. If possible, try to do things in your head. It just makes you feel better. Anyways, what's the process of rounding? Well, the goal here is to make the math easier. So let's think about this. All right, so let's think about if we have the number 37. Okay? We want to round it to the nearest tens place. Okay? The tens place would be in the 3. Okay? So what happens next? I look to the right of the place value I want to round. Okay, so if I'm looking at 37, 3 is the place value I'm looking at, and I look to the right, there's a 7. Now here's the rule. If it's 4 or less, the number stays the same. 4 or less, no change. 5 or more, you add 1. All right, so what's going on? I keep saying no change, add 1. But to what? To the underlying digit. So here we go. I want to round to the nearest tens place. Okay? I look at the 7. Well, okay, that's definitely 5 or more. So I add 1. I add 1 to the underlying digit. So I'm going to add 1. Now that the 3 becomes a 4. The place value to the right becomes, and everything else after it becomes a 0. Okay? So this last digit. After rounding, after you do your thing, after rounding all place values to, and forgive me for doing this, but around our space, become 0. Okay, now before we move on, I want you to see something. Okay, so we basically went from 37 to 40. Ooh, that's just perfect straight line. We went from 37 to 40. Now, we rounded the number. Okay? So, I always like to think of rounding as you want the number to be, well, for me, honestly, when I think of round numbers, I think of numbers that end in 0. But it doesn't always have to be like that. Okay? But it might help you make it into 0, 37 to 40. Let me give you another example, just real fast. Let me give you a decimal number, 1.2. I want to round it to the nearest ones place. Okay, so 1.2. Round to ones place. Okay, well, there's a 1 in the ones place. I look to the right. I notice that it's a 2. Well, if it's a 2, then the 1 stays the same. And everything else after becomes a 0. So you know what? Maybe I was right in saying the first thing that I said. When you're rounding, everything else at the end becomes 0. You want numbers that end in 0, basically. It's easy. They're easier to add. They're easier to subtract, to multiply and divide. For the most part. There's always exceptions to everything. But at this moment, I can't think of anything. So you'll have to trust me. And when we get to an example that you don't understand, by all means, please ask me or ask your teacher, and we'll work through it. Okay? So 1.2 rounded to the nearest ones place would be 1.0 or just 1, right? That would be a whole number. Now, what was I going to ask? Nah, it'll come to me later. Now, before we round, I also want you to understand something. This whole moving up or staying down, why does that work? Okay, let me give you a quick example, because I know one of the rules was 4 or less, stay the same, 5 or more, add 1. But why does that work? Okay, I want you to think of something. Just imagine we have the number 10, just for sake of argument. And on this side we have the number 20. Okay? And in the middle, of course, we have 15. Now what am I going to do here? I'm going to draw a little hill. Okay. Now, let's just say for the sake of argument that this is 14. You know, I'll just use a highlighter. Okay. 14. If this was a little ball on a hill, like I put my finger here, let's just pretend, use your imagination to put a ball right here on the hill, in the middle. I put my finger there to hold it, a little marble, I let go. Now, will the marble go to the 10? Or will it go all the way to 20? I'm pretty sure you're going to realize it goes to 10. Right? 14 will go to 10. But let's just say, well, wait a minute. What if we put our marble here, right on 15? Well, you know what? At that point, you could say, well, hey. Now, realistically, the marble could go back down the hill, or it could go back down towards the 20. Now, here's the deal. If I'm running, just to give you another example here, if I'm walking up a hill, and the goal is to get to the other side, if I'm at the very top of the hill, am I going to want to go back down the way I came? No. You're going to go all the way down to the other side of the hill. Okay? So, think of this. 14, right, ends in a 4. Look to the right, there's a 4. It's going to go back down. So the number stays the same. The number in the tens place stays the same. So 13, 12, 11, and 10, obviously. You round it off, it goes to 10. 4 or less, and the number stays the same. The number that you're trying to estimate or round stays the same. Now, if we go the other side, well, guess what? All these numbers are going to go to 20. So 15, you're already here. Might as well go all the way. 16, go all the way. And so forth and so on. Okay? Now, another way to say it, let's say 5 or more, raise the score. 4 or less, let it rest. 4 or less, let it rest. 5 or more, raise the score. Okay? It's just a rule for rounding. Okay? If whatever number your place value you're looking at, and if you want to round it, either the number will go up or down based on what's to the right of it. Okay? So anyways, I hope this helps. Let's just do this, because the best way to learn it is to actually do it. So let me give you an example. Here we have, this is page 186. Example 1. 8.7 times 2.8. Okay, here's the deal. Before you do anything else, what's the greatest place value? I'm noticing here we have a ones place, here we have a ones place. All right. Ones, ones. They both have the same place value. They both have the same greatest place value. Okay, so that means you're going to round to the nearest ones. Okay, so 8.7, 2.8. I look to the right. You know what? 8.7. The 7 is obviously more than 5, so I'm going to add 1 to this. And this becomes 0. This, I look to the right. It is an 8, definitely more than 5, so this becomes 3, and this becomes 0. So now I just have 9 times 3. And that's just 27. So, again, this is just an estimate. This is about, so 8.7 times 2.8 is about 27. Okay? Now, is there another way to do this that might make this easier to see? Let me show you. See what you guys think. And again, I ask your forgiveness with the super not straight lines, so I'm going to fold it just a little bit. Yeesh. I was doing fine until I got the end. All right. 8.7 times 2.8. Same deal. Same numbers. Nothing changed. But I want you to realize something. Whenever you're rounding, basically, you're looking at the value that you're rounding and the number next to it. So you're really focusing on two things. Now, this is easy. You can only see two things because there's only two things. But sometimes there'll be more digits that you have to worry about later. For right now, let's just focus on this. Can you think of, can you count from 0 to 100 by tens? I think most of you can, right? So after 87 comes 90. Before 87 becomes 80. Before 28 becomes 20. And after 28 comes 30. Now you're thinking, wait, but that's not really 20, that's not really 30. It's 2.8, 8.7. For the moment, I'm forgetting the decimal point. I'm just going to imagine that it's not there. Now, if you remember the little hill that I drew, here's 80, here's 90, 85 is in the middle, 87 is right here. It's going to go to 90. Okay, so 87 becomes 90, but really it's not 90, it's 9.0. 28, here's 30, here's 20, 25 in the middle, 28's right there somewhere. It's going to go straight to 30. But it's not 30, it's 3.0. Or just basically 9 times 3, same answer. Okay? I think so far, I think we're good. Let's look at example number 2. We have 42.6 times 37.2. Okay, same thing. What is the highest place value? That matters. That really does matter, believe it or not. All right, I'm looking. The highest place value here is the tens place. And this one's also the tens place. So tens. So I guess we're rounding to the tens place. If they're both the same, That's what you round to. Okay, so I guess we're rounding to the nearest tens place. Now see, now we're going to talk about something that I mentioned earlier. All right, 42.6. We're focusing on the tens place. I look to the right. It's 2, right? That's less than 5. Actually, that's less than 4. So the 4 stays the same. This becomes 0. This becomes 0. Don't forget the decimal point. It matters. Okay? 3. We'll have 37.2. The 3 is in the tens place. I look to the right. That's 5 or more because it's 7. 7 is more than 5. I add 1 to the 3. Right? It becomes 40. This becomes, excuse me, I go a little ahead of time here. It becomes 4. And everything else after becomes 0. And again, don't forget that decimal point. Or 40 times 40. And if you do the math, 0 times 0, 0 times 4, 4 times 0, 4 times 4, place value holder, 0, 0, 6. All right, so the answer then. Don't put the little comma. Okay. That's really all it is. You're just focusing on the place value that you're rounding and the number next to it. If there were numbers before here, that wouldn't matter. That wouldn't change it. If there are numbers after, well, that becomes 0. But really, you're just focusing on those two things. And again, if I were to show you the little hill action here. All right. Here's 40. Here's 50. 42 is here. It's going to go to 40. 37. We have 30. We have 40. In the middle, we have 35. 37 is right there. It's going to go to 40. Okay. Oh, you didn't see what I just did. I apologize for that. What I did was I visualized the numbers again. I have 42.6 at the very top. 42. 42 is right here somewhere. 42 is going to go to 40. On this side, I have 37. 37 will go straight to 40. So if you forget the rules, then just count by tens. Okay, but really, the rules aren't that hard. But hey, who am I to say anything, right? You do what works best for you. All right, 2. One more example. I know these notes are getting huge. Don't worry, we're almost done here. All right, let's see. We give you... It's a word problem, but you know what? I'm just going to give you the numbers because right now I just want you to understand. I want you to know the process, okay? 39.3 times 6.5. Okay. Again, I ask, what is the greatest place value? Now here we're going to have a problem. Maybe. Here we have a tens place. Here we have a ones place. Tens place. Here we have a ones place. I should have wrote the number. I don't know why I wrote the word. But that's okay. You know what? Let's fix this. Magic. Magic. A little sloppy. Ta-da! Now it becomes a tens place. What is the greatest place value? It's one has the tens, the other has the ones. You're going to multiply... I was going to say only the large one. I'm trying to think how the best way to say this. I had a moment of silence there. Multiply the largest by tens. and the smallest by ones. Now, when I say that, I think I phrased it incorrectly. It doesn't make sense. You're not multiplying anything. Okay? You're going to round to the nearest tens. You're going to round to the nearest one. So, I'm going to fix my mistake. I don't like that. I'm thinking ahead. Round only the largest by tens and the smallest by one. Okay? Now, in a moment, I'll tell you why. Okay. So 39.3. I look to the right. I add 1. It becomes 4. And this becomes 0. Decimal point. This becomes 0. 6.5. All right. I look to the right. And I add 1 to this. That's plus 1. That's 7. That becomes 0. $280. Okay, 6.5 is approximately 280. Okay, now I did ask, or I did say, I was going to tell you why we didn't round this to the nearest tens place. Sometimes you will. Depends on the number. It has to be a very special occasion. Okay? So let me explain what happened. I'm going to redo it just a little differently. Okay. Okay, now this has a tens place. There is a tens place there in a sense. It's 0. There is no the value of the tens place in that number would be 0, but it is there. Okay, you just don't write it because, well, it means nothing. So here's the deal. I do the same thing. That becomes 4. That becomes 0. That becomes 0. Now, this is going to be weird. Because you know what? Sometimes the directions will say round to the nearest tens. But then you're going to say, but there's no tens place. This is where you have to use your little imagination, put a little place value holder, and then do what you got to do. I have 0. I look to the right. 5 or more, I add 1. That's 1. That becomes 0. That becomes 0. All right. Now, you have 40 times 10. Oh my goodness. Now it becomes 400. So you're saying with this one, 39.3 times 6.5 is approximately 400? Well, that can't be right. If you actually do the math, 39.3 times 6.5, the actual answer is 255. And let's think of money. $255.45. Okay. If you're paying someone, if you're thinking how much you have to pay people for a job that you're doing, or no, excuse me, if you're paying for someone to do a job for you, and you're thinking about in your head how much you have to pay them, this is pretty close to what you actually have to pay. This is way off. That's paying way too much, right? You're giving away too much money as an estimate. You're going to overestimate the cost of whatever it is you're doing, that you're paying the other person to do. So this is why we didn't do the tens place for this one. Okay? It's too much of a value. It's only 6, right? It's easier to say that it's closer to, well, what did we say it was closer to? 7. That makes more sense. Okay? A big difference from 7 to 10. It may not seem like much, but when you multiply it by this many times, it does make a big difference. All right, so let me simplify that, what I just said. All this. When you're estimating, you want to stay as close to the original value as possible. Okay? 7 is pretty close to 6.5. No one can deny that. 10 is close, but a more precise answer, a better estimate would be 7. Okay? 40 is pretty close to this, so it makes sense. This is a more reasonable estimate. Okay? Now, I know I said I mixed up my examples of saying, okay, pretend you have to pay someone for a job that you have to do. I did it again, didn't I? For a job, you have to pay someone for a job that you want done. Okay? And if the person doing the job for you gives you an estimate of $280, okay, that's not bad. When you know for a fact it's this, okay, well, this guy's pretty reasonable. But if someone gives you an estimate of $400, you're like, okay, that doesn't make any sense. So this is a more reasonable estimate. Okay? All right, one more example, then we'll be done with this. Or I think we're good here. I truly do. Let's do one more. It can't hurt, right? Can't hurt to do more. I think we can do this fairly quickly. This is example number 4. $48.50 times 5.8 Egyptian pounds. Okay, now actually, and this is an example from the book. Let me read it to you. Suppose the US dollar is equal to 5.8 Egyptian pounds. About how many Egyptian pounds would you receive for $48.50? Okay, well, you want to have an accurate amount, right? You're changing money from dollars to Egyptian pounds, another form of currency. Okay, but same thing. What is the greatest place value? Here we have tens. Here we have ones. No, okay. This one around to the nearest tens place. This one around the nearest ones place. So here we go again. And in a moment, I'm going to give you an example where things will be a little different. All right. Underline the place value that I'm looking at. I look to the right. 8 is more than 5. 5, right? 5 or more. So add 1. That becomes 5. 0. 0. 0. Look to the right. This becomes 0. Okay. 50 times 6. I can do that in my head. That's about $300. Or 300 pounds in this case. But since I didn't really give you the full word problem, let's just say $300. Fine. That makes sense. Okay, that's reasonable. Now, let me give you another example where things get a little different. Oh no, what are you going to do now? All right, the same idea. Nothing changes. It's still going to be what we said it's going to be, and I'll show you why. You look to the right, you add 1. That becomes 0. Decimal point, 0. 0. All right, now, you're going to add 1, right? Because this is 5 or more. We're looking at the ones place. You add 1. What's 9 plus 1? 10. And this becomes 0, 10.0. And you should look at it. 9.8 is pretty close to 10.0. Okay? And then 50 times 10 is 500. Okay? That's reasonable. This is a reasonable answer for this. Okay? If we had switched this to 10, right, nearest tens place, this would have rounded up to 10. And you have the same problems you did before. Okay, I hope this helps.